It's time to think differently about thermal management for today's aircraft and engines. The advent of more electric aircraft, the growing use of composites for construction, and the higher demands on engines for thrust and power generation are resulting in hotter environments, hotter fluids, and hotter component temperatures, making thermal management for military and commercial aircraft increasingly critical. So how do you cool an aircraft that generates thousands of BTUs a minute? At Parker Aerospace, we've developed an innovative, game-changing approach. Our advanced thermal management technology provides solutions that can be formed into virtually limitless shapes and profiles to pull high levels of heat out of the aircraft. Advanced thermal management can be applied to internal components, subsystems, systems, or the airframe itself, cooling engines, hydraulics, flight controls, and electronics, as well as providing anti-icing for wings and stabilizers. Let's take a closer look at the advantages this breakthrough technology can offer you. Currently, engines are cooled with heat exchangers, which significantly disrupt bypass airflow due to their large cooling surface requirements, putting unnecessary drag on engine power output. Our advanced thermal management conformal heat exchangers offer a much lower profile with significantly less disruption of airflow, which creates substantially higher engine output. At the same time, Parker's conformal heat exchangers deliver better heat removal than conventional heat exchangers. Engine heat can also be fully managed using our advanced thermal management active skin technology, which integrates the heat management function directly into the skin of the nacelle, wing, or fuselage. The advantages? High levels of heat removal with even lower weight in a smaller envelope. This unique approach is enabled by cooling channel fabrication and bonding techniques developed by Parker over the last 15 years. Active skin panels can perform structural duties and can incorporate thousands of internal channels for the circulation of thermal management fluids such as lubrication oil, fuel, or hydraulic fluid, with the potential of reusing the heat for anti-icing and subsystem heating. For hydraulic system cooling, active skins can be integrated into aircraft surfaces to cool hydraulic fluid. Here, the active panel has been installed on the wing surface to reject heat into the ambient airstream rather than into the aircraft's fuel. Where required, integrated manifolds minimize the need for hoses and fittings. Active skin panels can play another important role in thermal management. They can be used to redistribute heat to surfaces that require anti-icing capabilities such as wings, engine cowlings, and tail flight control surfaces. Other applications of our advanced thermal management technology include independent or remote subsystems such as jam-tolerant electromechanical actuators. Here, the motor cover is made of advanced thermal management active sheet metal, and the controller houses liquid flow-through capabilities. The closed-loop subsystem removes heat from the motor and controller and sends it to an active skin heat exchanger, resulting in more compact designs. The thermal management subsystem is powered by a motor-controlled pump module. Electronics cooling is also significantly improved with Parker Advanced Thermal Management. Here, electronics bay cooling is achieved using proven Parker liquid-cooled chassis and heat rejection units. Together, these products provide cooling rates up to 100 times more effective than those of existing cooling technologies. In order to survive in today's challenging engine environments, combustors require thermal management for each fuel nozzle. Parker's advanced thermal management technology is in all of our industry-leading fuel nozzles on thousands of aircraft flying today, including the 787, A320, and F-22. Parker's advanced thermal management technology, revolutionary integrated thermal management solutions that are more efficient, smaller, and lighter for heat-heavy aircraft. Configurable into virtually limitless shapes and profiles for greater design flexibility, providing aerospace designers the freedom to think differently and move thermal management for today's aircraft and engines in an entirely new direction.